So in this video, we will talk about BGP egress traffic. How can we control traffic with BGP using its attribute called local preference? So local preference is a highest priority attribute that BGP prefers. And in this video, we will configure this topology with VOS1 and AS1 advertising this prefix 111.111/32. These are the transit links, and then in BGP AS23 we'll have VOS2 and 3 connected with 23.000.2.3. We'll configure the links, configure BGP, advertise this prefix, and see that this prefix will get learned by VOS1 on this path and by VOS3 on this path. So therefore, any packets arriving to VOS2 and 3 would take this path going out for this prefix or this network. But what we'll do is we will put a route map on VOS3, policy, and a route map that would say that when I learn this prefix on this link, set the local preference to non-default. The default is 100, and so we will set it to, let's just say, 300 or whatever. What that would do is when the inbound policy is set with this route map and setting the local preference to 300, VOS3 will advertise this to VOS2, and then VOS2 will say, okay, so you got a better local preference, the higher the better. And then the packets coming to VOS2 would go like this, exiting this AS instead of exiting here. And we'll see this with this configuration. So let's bring up router 1, 2, and 3. Nothing is configured on them, so I'll configure the links and the ASs. Set interface Ethernet 1 address 12.0.0.1/24. Ethernet 2 address 13.0.0.1/24. Dummy interface DUM0 address 111/32. Set protocol BGP AS1. Neighbor 12.0.0.2, remote AS is going to be 23, and the other link is 13.0.0.3. Remote AS is the same, and then I'm going to advertise network 111/32. Commit. This is done on VOS1. It's ready to peer with 2. Configure set interface Ethernet 1 address 12.0.0.2. Ethernet 2 address 23.02. Set protocol BGP AS number 23, neighbor is 12.0.1, remote AS is 1, 23.0.0.3, remote AS is 23, that's the internal. And when you set the remote AS as internal, a good practice is to do next hop self. Otherwise, anything coming out of this way and then getting advertised. So if 111.1.1 is advertised this way, he will learn and he will give it to VOS3, but when BGP advertises this prefix, his next hop is 12.0.0.1. 12.0.0.1 may not be reachable by VIOS 3, so he's not going to install it. So install that route. So when VIOS 2 says, hey, I am sending you this prefix, and therefore my next hop, the next hop for this prefix is going to be this address. To do that, you're going to have to set this command that we will do for VIOS 2 and VIOS 3. So we'll do, let's just skip this command and let me show you first how the next hop is 12.0.1 for this. So we got the peers up, we got the interfaces up, we do the commit. VIOS configure set interface Ethernet 1, address is 13.0.0.3/24. Address is 23.0.0.3/24. Set protocol BGP AS-23. Remote AS is neighbor 13.0.0.1. Remote AS is 1. And then the internal one is neighbor 23.0.0.2. Remote AS is 23. Commit this. BGP takes a little time to come up, so run show IP BGP summary. I've got the neighbors up. I've also got a prefix coming in, which is the one that we advertised from VIOS 1. Run show IP BGP. We see that we have 111.111 coming from 13.0.1, this guy, and coming from 12.0.0.1. See the next hop for this guy, 111 is 13.0.1, which is this guy. And so for VIOS 2 to reach 13.0.1 may not be possible because it's not advertised anywhere. You'll see the same thing, show IP BGP, that 111.111 is coming from 13.0.1, and that's the one that's preferred with the arrow. And the 12.0.0.1 is not preferred because it's not reachable. Default local preference is 100. So what we will do is we're going to say set protocol BGP 23 neighbor 23.0.0.3 next hop self. Commit set protocol BGP 23 neighbor 23.0.2 next hop self. And then check the IGP table, BGP table, and look at this. The next hop has changed from 12.0.1 to 23.0.3, okay, which is his own next hop. Same thing would be here. Show IP BGP 23.0.2. Okay, now it's reachable because it's connected on a direct link. So now if you run the trace, it's going to go for, so run show IP route will show you that BGP is coming through 12.0.0.1, which is this, and it's reachable, right? But now what we want to do is, since this is your AS and you want to influence the traffic going out and egress traffic going out, instead of from here, you want to influence it from V3. To do that, we will configure our route map, policy route map, set protocol, set policy, route map, call it set local pref, and you can call whatever you want. Rule 1 action permit set local preference, let's just say 300. And then apply this set protocol BGP neighbor to this neighbor, because we're getting this prefix and we're preferring this guy, this path over this path. So whatever comes this way, we set the local preference and then we advertise it to 2. So we go BGP neighbor neighbor 13 route map import set local preference commit. Now BGP by default would not update this because we have not configured inbound soft configuration. So for the sake of simplicity, we'll just reset BGP. So make sure that we notice one more time, unshow IP route. 111 is going through 1301, which is this guy. Unshow IP route. He's going through 12001. And then after we reset this, apply that policy, he's going to go through 23002. This guy is going to go through 23002, right? All right. So we do run a reset IP BGP all. It's going to take a little minute. Show IP BGP summary. It's still idle. Still idle. It's up. Show IP summary up. Check out the route here. Run show IP route. Look where it's going from. 23003. Let's show IP BGP. I'm going from 23, instead of going to 12001, which is directly, I've influenced it to go through 23003, this route. Make sure this is next hop self is configured because otherwise I'm going to take it. So now I'm going for VOS2 instead of directly going through, and now I'm going through 23003, this route. All right. But if I do a trace route, my VOS1 does not have 23003. So only when you advertise 23003 would your trace route be successful. But you can now see how the local preference set to 300 on this inbound can influence your traffic coming from here. Instead of taking the default, it's now getting influenced through here. Now, if you want to do the trace route, like I said, you can do, quick one is to just say set protocol BGP 23. Right now it's not going to run, right? The trace route is going to fail because when you run the trace route from here, it's going to take 23002 as a source address. It's going to go here. The source address is 23002. It's going to reach BGP AS, and BGP AS VOS1 is going to say, I don't know where 23001 is or 2 is, right? So your trace route is going to look like something trace 111 like this. See that? So it's just going to fail because he's not able to respond back to the source. So now what you're going to do is you're going to advertise 230 subnet, or you just put a static route, either way. Set protocol BGP 23 network 23. Set protocol BGP 23 network 23. Make sure that this is learned. BGP takes a while to learn things. There it is, 23. Now run the trace route. There you go. So you are not going through the directly connected 12.0, you're going through 23.003. Hope this helps in terms of BGP egress traffic. Local preference, you can use AS Prepend, but local preference takes preference over AS-Path as well. Hope this helps.